I'm Christa, and today I'm going to be telling you all about logistic regression in SAS. First, I'm going to be showing you a brief introduction to logistic regression, and then we're going to be moving over to SAS Studio, where I'm going to show you how to do a few things with your data and fit the model. And then last, I'm going to be moving over to Model Studio, where I'm going to show you how to do some similar tasks. Alright, let's get started. So first, I'm going to be going into a brief introduction to logistic regression, starting off by comparing it to linear regression. So we have some data here in the left-hand corner. This is going to be weight plotted against age. So as you can see, as the age increases, so does the weight. So if we wanted to fit a linear regression to this data, it would look something like this. So it's just a straight line fitted through the data, and as you can see with at least this example, it fits pretty well. So here is the equation for linear regression. So we have x, which is our explanatory variable, and we have y, which is our dependent variable. We also have b1, which is the slope of the line that you can see, b0, which is the intercept, so that's the value of y when x is equal to 0, and we have an error term. So if you look up linear regression or logistic regression, you may or may not see the error term, but this is generally always in there. It's not always represented when people are doing the equations. And the method that linear regression uses to fit the model to the data is least squares. Alright, so now I'm moving over to logistic regression. So the main difference between logistic and linear regression is the data that you're trying to predict. So in this example, we're looking at a binary target. Logistic regression tends to look at only discrete values. So it could be binary, it could have multiple levels, but they're all discrete. So the reason why you wouldn't use linear regression to plot something like this is if we have data like in this plot here with ones at the top and zeros at the bottom to represent our target. And let's say that we're looking at the comparison of will it rain, so is it raining, would be 1, and it's not raining is 0 against the humidity. So as we have an increase in humidity, you're more and more likely for it to be raining. So if I were to plot a linear regression to this, it might look something like this. So these values will range from negative infinity to positive infinity, when really all we want is something that is constrained by zeros and 1. So this is where logistic regression comes in. So if we were to plot logistic regression to this instead, what we'll end up with is a line that looks kind of like an S. So it stops at 0, or it plateaus at 0, and it also plateaus out at 1. And in the middle, it's trying to capture where that data is overlapping. So is it more likely at this point that it's going to be raining, or is it more likely at this point that it's not going to be raining? So it tries to capture that variance in the data. So the equation for this has some of the similar variables that we saw in the linear regression. So we have b0, b1, x1, and those are representing the variables that we're using as the input. So this can handle both interval and categorical data. And instead of using least squares like linear regression, it uses the maximum likelihood estimation. So that's how it's estimating the model coefficients. And similar to the linear regression, you can also have more than one variable. So here's the equation with more out. You can see it pretty much looks exactly like the linear regression, except now we have it in this kind of form, and that constrains our values to be between 0 and 1, which are the only things that we're interested in predicting. So it's just showing us what is the probability that each of our target events will happen. So if you were actually trying to classify, instead you could just set a threshold. So if it was above 0.5, we're going to say that it's raining. If it's below 0.5, we're going to say that it's not raining. But our logistic regression will just output that probability. So that's a threshold that you would have to decide. Okay, so now we're moving over to SAS Studio. So first, I'm going to be showing you the example compare two ML algorithms. So I chose this example because it has an example of logistic regression, and it also compares it to a decision tree. So if I scroll down, I'm going to show you the proc that we're using. So it's using the log select. So I have this pulled up here. So if you were to look up things about log select, you can find more information. This just gives you some basic information, but it also shows you this procedure compared to the proc logistic. So logistic is another way that you can do logistic regression in SAS. I'm just going to be using log select today, but if you were wanting to do something like that, it has tons of information on this page. So you can find out how to handle missing values, how it's doing the odds ratio estimation, the goodness of fit tests, and it also has some examples using logistic regression. If you were interested in doing something with more than just binary targets, there's also a great paper that gives you a few examples using ordinal and nominal dependent variables. So I'm going to link to everything below, and you can check that out when you need to, or if you need to. But now I'm going to get back to this example. So I'm going to start off, and I'm just going to run the setup and initialization. Now I'm going to run this bit of code. So it says check if the HMEQ prepped data has been created. So I'm going to run this, and it tells us that we haven't ran that yet. So it's telling us to remember to run the prepare and explore data snippet. So I'm going to pull this up. And what this does is it loads the data for one, but it also does imputation. It identifies variables that explain variance in your data, and it also performs a cluster analysis on two different variables that can help improve your model. I'm going to submit this code. And so it's running, it's doing things like plotting the percentage of missing values, which you can see here. You can also look at the table, which shows you the exact number of missing values for each of your variables. But as you can see in this graph, with this being 21% missing values, this is 11, there's quite a bit of missing values in this data. So if you're using data that has a high percentage of missing values, you're most likely going to have to handle it somehow. If you don't, you probably aren't going to have a good fit to your data. So some of the other things that the prepare and explore goes through is clustering. So this clusters two of your variables, the CL age and the depth to income ratio. So it clusters based on the interval inputs and creates clusters of 6. So this can help improve your model if 6 clusters better represents the data than the individual intervals, because it might just be easier to be able to do something with. And at the very bottom, you can see stuff related to the PCA analysis it did, and plots for the variance explained. So if you're looking for more information about your data before you get started, so if you wanted to remove some of your variables to make the analysis easier, this would be very helpful. So now that we've done this, when I run this bit of code, it should show us that our data is now loaded. Okay, so there was no error. We now have our data to begin. Okay, so now I'm going to partition the data. So this partitions the data into a sample of 70% for our training, with the remaining used for validation. And it generates this plot, which shows us how many of each of our target variables were used in the final sample size. Okay, so now we're going to do the logistic regression. So again, we're using the log select version. There are other procedures available if you wanted to do logistic regression in a different way, and examples available for them. So I'm going to go ahead and run all of the remaining code. So what this code is going to do is fit our model, then it's going to score and assess the model, and then run a decision tree and score and assess that model. So if I select the rest of this code, what we're getting is 2 models fitted, and then some plots showing a comparison of these 2 models. So this is the ROC and lift plots using the validation that we partitioned earlier. Okay, so with our logistic regression model, you have a few bits of information. You can see how significant the model was and the variables that were used. For the decision tree, you can also see similar information, including a plot of the tree and a subtree, so an example of where the main splits are occurring in your data from the beginning. And here we see the ROC curve. So between the logistic regression that we did and the tree that we created, the tree is fitting better, but that might not always be the case. So it really depends on your data. This is just an example. So if you were doing this, you might want to try out multiple algorithms to see which one is a better fit, but it's not always the case that one is better than the other. Okay, so now I'm going to move over to Model Studio. So I'm going to start off by creating a project. I'm just going to name this example. And then I'm going to be choosing a template. So there's already a template available that has what we need. So I have a data, imputation, logistic regression, and a model comparison node. So I'm going to be adding a few things to this, but for a start, this has a majority of the nodes that we need. So I'm going to import our data. Okay, so now we have our data loaded into our pipeline. So if you scroll over, you can see the pipeline of the template that we selected, but it's telling us a warning that we must assign the variable the role of target in order to start the pipeline. So I'm going to go back over here and make a few changes. So the first thing I'm going to do is set our variable name bad as the target. The next thing I'm going to do is when SAS loaded this data in, some of these variables are interval, but it listed them as nominal. So I'm going to go ahead and change the ones that should be interval. So in this case, is every one listed as nominal besides job. So I'm changing those back to interval. And then the next thing I'm going to do is, as you can see, we have our imputation node in our pipeline, but that doesn't mean that it's going to be doing the imputation like we did in SAS Studio. So real quick, I'm going to go back over to SAS Studio and show you what we did in the Prepare and Explore. So the reason why I'm doing this is I want to try and get a similar model. So it's going to be a little bit different just based on maybe the implementation and a different sample, but I'm trying to get it as close to this as possible. So when we were in SAS Studio, when we ran the Prepare and Explore data, it imputed the missing values based on this procedure. So we updated the CLAGE to be the mean, anywhere it was missing, the delink to be median, the NINQ to be random, so it was just selecting a random value for each of those missing variables, and then the depth to income and the YOJ were both set to a custom value of 50 and 100 respectively. So I'm going to try and replicate that over in Model Studio. So by default, the imputation node will do count for class inputs and mean for the interval inputs. But what I want is to have specific things for each of those variables. So the first thing we did was impute the CLAGE to be the mean. So I'm going to go over here and change its option to show mean instead of default. The next thing that we did was change the DELINQ to be imputed to the median. And the NINQ to random. So in Model Studio, there isn't a random. So what I'm going to do for this case is just put it to the mean. So it might not be exactly how you saw it in SAS Studio, but this is the workaround for this. Or the workaround that I'm doing at least. Okay. So the next thing we do is we're going to set the depth to income to be 50 and then the YOJ to be 100. So we're going to select that we want to do a custom constant value. So for this one, it was 50. And for the YOJ, we're doing the same thing except using 100. All right, so at this point, all of our data should be ready to go. We have our imputation set to how we want it to be performing in the pipeline. The only thing that we need to do is make sure that we're not doing imputation for anything else. So we just want it to do the imputation that we specified. So I'm going to set the class inputs to none and the interval inputs to none also. So what this will do is it'll just run imputation for what we set over in the data tab, but it's not going to do any imputation on any of the other variables that have missing values. So if you wanted it to do that, you could just leave what I had here that I changed to none to the default, or you could update it to be whatever you wanted it to impute to. So I'm going to run the pipeline now. All right, so our pipeline has successfully ran. I'm going to right-click on the Logistic Regression node and look at the results. So in this window, on the node window, you can see different variables. You can look at the parameter estimates. So you can see the significance of each of those variables along with the intercept. You can also look at the regression fit statistics. And you can view different things like the node score code, the score inputs, and various other tables of information. So these are all similar to some of the things that we generated, but this is just auto-generated in Model Studio. If we go over to the Assessment tab, we can look at the lift reports and the ROC reports. So if I open this up, it actually gives us quite a bit of information explaining what these plots look like. So if you aren't very familiar with it, you can expand and then get a basic description of what this plot was showing you and what it represents. So here we can see that our model fits okay. It's not very great. What we really want is something that goes more all the way up and over and fits this line, meaning that it doesn't have, or it's all true positives and it's not really having any false positives. So now what I'm going to do is incorporate the clustering that we saw over in the SAS Studio. So I'm going to add that to our model and see if we get any improvement. So I'm opening up the nodes, the data mining preprocessing tab, and dragging over the variable clustering. I'm going to drop it right in between the imputation and the logistic regression node. So I'm just going to leave this with the default values. So over in SAS Studio, we specified the two variables we wanted to cluster, but I'm just going to let it cluster the variables as it sees fit and rerun the pipeline. Alright, so our pipeline has successfully reran, and I'm going to open the results of the logistic regression node like we did before. This time I'm going to go straight over to the assessment tab. I'm going to look at the ROC. So it has changed and has improved quite a bit, but it's still around the same. So if we flip over, you can also see the accuracy. So if you're wanting to see how that's plotting, and the F1 score, you can do that. Just switch between using the drop down. So now what I'm going to do for a bigger comparison is just add a logistic regression node in without these data preprocessing that we did. So I'm going to drag it, and I'm going to attach it to the data tab. So this will give us a comparison to compare what we've done when we did the imputation and the variable clustering compared to just running logistic regression solely on our data without any preprocessing. So now it's successfully ran, and I'm going to open up the model comparison node. So as you can see here, the champion model is the logistic regression that we initially created. So it did quite a bit better than the one without the variable clustering and imputation, which makes sense because it was dealing with a lot of missing values and also higher levels of data. So if I scroll over, you can see the accuracy. So our model that we used the preprocessing on is around 90%, whereas the model that we didn't is around 80%. And you can also view the F1 score, the ROC, and the false positive rate all in this chart. If you want to view the plots for it, that is also available. You can look at them separately, going into the actual logistic regression without the preprocessing. We can see our ROC and our accuracy of that also. So the last thing I'm going to talk about is why would you want to use logistic regression in this case? A lot of people will throw a neural network at anything. So what I'm going to do is I'm going to add a neural network to this chain where we've done the imputation and the variable clustering. So logistic regression is simpler. So a reason that you would choose something like this over it, besides if it does perform better, is that it uses less resources and time. So it's going to take longer to train the neural network in a lot of cases, and it also might be using more resources in general. So I'm running the pipeline right now, and when it's done, I'm going to open the model comparison node, and we can compare all three of these models together. So now that our model has successfully ran again, I'm going to right-click on the model comparison and open the results. So as you can see here, the logistic regression is still the champion model, so the one that we did with preprocessing. So depending on what data that you have and what you're looking at, it might be best to choose logistic regression. Even though it is simpler, it might perform better on your data. So these are all things to take in consideration. And if you have different things you want to do, maybe if you want to try and improve your logistic regression, there's plenty of options here. If you click on the node, you can change the target link function, you can change the selection method, and you can open up all of these drop downs and change what your criterions are, how long your model's training for, and your convergence cutoffs. So you have plenty of options to mess with your model and improve it through that. So besides just the data preprocessing, you have plenty of options that you can go through. So I hope you enjoyed this video on logistic regression in SAS, and if you did enjoy it, make sure you subscribe to the channel. There are related links and things that I mentioned in the video in the description below, and if you have any comments, feel free to leave them. Thanks for watching.